Kia ora team. Today we're going to talk about earth continuity testing in an installation. So that means that we're testing the continuity of our earthing wires inside the installation. That is both the main earthing conductor, which runs from my switchboard from the earth buzz bar out to my earth stake, and also the internal earth conductors, such as the earth conductors in my sub-circuits and any bonding conductors that are connecting from the earth buzz bar in my switchboard out to extraneous metal parts, as we call them, other metal things that are in the installation, like steel benches, copper pipes, things like that. Those typically need to be connected to our earthing system as well. So part of our earth continuity testing is to test that. Let's have a quick look at what we are going to do. So I have my switchboard here. A couple of points before we start. This switchboard is not currently connected to power. This is just freestanding on my desk. And you will note that I have removed the earth neutral link. The earth neutral link is not present. That is because I'm currently testing it and I've removed it for testing purposes. We should not generally ever need to remove the earthing link in a live installation. So please just note that I've done that for testing purposes. I have here a simulated earth stake. You can see it looks like the top of an earth stake. That's just a simulation for the purposes of this demo. And that wire there with my my earth conductor tag on there running into the switchboard and up to my earth buzz bar. I also have a socket here. Once again, this is not screwed to a wall or anything like it normally would be, but you can see this is running into the switchboard and is connected from the circuit breaker, and the earth is connected to my earth buzz bar neutral to the neutral buzz bar. Again, this is just for purposes of demonstration. Normally, we would not see a socket sitting inside a switchboard like this. Okay, so the next thing we will look at then is our standard ASNZ3000. And what does that say about our testing? Well, I'm going to go once again to section 8, because section 8 contains all of our testing. And if I scroll down to 8.3.2 here, you will see it tells us about some of the mandatory tests, 8.3.3 rather. And one of them is continuity of earthing system, earth resistance of the main earthing conductor, predictive earthing conductors, and bonding conductors. So those are the three things that we just mentioned. If I scroll down a bit, we will see 8.3.4 tells us our sequence of testing. And we see there that earth resistance test, continuity of main earthing conductor, earth resistance test for other earth and equipotential bonding parts are our first two tests. So these are the first ones that I'm going to do when I'm commissioning a new installation, or when I'm testing a new installation before I commission it. So let's scroll down then to here, where it tells us about the continuity of the earthing system. I'm not going to read that in detail for you. You can find that yourself, 8.3.5 of ASNZ3000. And if we look here, results. So what does the value need to be when I do that test? Well, it says here that resistance of the main earthing conductor or any bonding conductor should not be more than 0.5 ohms. So our main earth and our bonding conductors must be 0.5 or less. And if I look down here in the notes, it says maximum resistance values for earthing conductors, so that's out to our sub-circuits, are given in table 8.2 as a function of conductor size and rating of the associated overcurrent protection device. So there's a table there that tells me what value of resistance is allowable in the earthing conductor running from my socket in this case, or it could be a lighting circuit or whatever you've got in your installation. And remember, we must test every sub-circuit in the installation. So the maximum value of the earth conductor between here back to the earth buzz bar is given in table 8.2, and we will look at that shortly. But let's start then with our test for our main earth conductor. This is a very simple test. I'm testing for resistance. My meter is set to the ohms scale, and I put one end onto my earth buzz bar, and the other end goes to the other side of my main earth conductor out to my earth stake. And we can see the reading there is 0.3 ohms. Perfect. It must be no greater than 0.5 or 0.5 or less. You just see that it's switched down to 0.2. So we've got a very low reading there. That's fantastic. My main earthing conductor in this case is good. It should be good because I can see the whole thing. It's a nice big 6 mil and it's only very short. So we should have very little resistance in that circuit. Okay, so the next test we would then do is earth bonding conductors. I don't have any bonding conductors here, but if you have installed bonding conductors in your installation, again to our water pipes, steel benches, anything like that, now we would test those. And the third test we do is the earthing conductor here. Now, if I wanted to do this test on this particular switchboard, that would be very easy. I plug this end of my lead into the earth socket, or the earth socket on my outlet here, and the other end goes up here. And you can see I get a very low reading, 0.3, 0.2, 0.3 again. Fantastic. But you may be watching this and think, hold on, if that socket is at the other end of the house or, well, even on the other side of in the same room as the switchboard, but on the other side of the room, my meter leads are not long enough to do that, and you would be right. This is quite a difficult test to do with standard meter leads if I need to go all the way around the house and test the earth connection on every socket and again on every lighting point, etc., etc. In fact, it would be almost impossible. So there is a methodology that is described in the standard that allows us to do this, and that is to connect my phase conductor to the earth busbar. Now, it's important to note here that I will only do this on a switchboard that is not live, right? That makes sense, doesn't it? Because if I start connecting my phase to my earth on a live switchboard, terrible things are going to happen. So I can assure you that this is not live. If we were doing a new installation, I would be doing this before the mains is connected. So before the mains is connected, I'm going to run a wire from my main switch. I'll do that now. It's nice and securely in there, and I'm going to connect that to my earth busbar. There we go. So why are you doing this, you ask? What is the point? Well, now what this allows me to do is to just switch my lead out here so I've got 2 probes instead of a clip, is if we imagine that I'm at this socket here, and this is in a different room to my switchboard, and I want to test that earth conductor, I can now go from the live conductor, test the live conductor to the earth conductor. So my test current will now go down the earth conductor to my earth busbar, through this wire that I have installed here, to my phase. All of my phases in the installation are connected off here, so it'll go back through my circuit breaker, onto that sub-circuit, and back to my live here. So now I should get a reading between my live conductor and my earth conductor right here at the socket. Oh, I have to go into the neutral first to open the shutter, which will allow me to connect to the phase, and then I can go to the earth. And you can see on my meter there, I've got a reading of 0.3. Oh, it's fantastic. Now you can imagine if I was doing this earth continuity testing throughout an installation, there may be many sockets, 20, 30, 40 sockets, and probably as many lighting points and various other items of electrical equipment. So this could be quite a time-consuming test to go all around the house and do this. And this little connection here allows me to do this much, much more easily. So I connect that up, do my earth continuity testing all the way around the house, and then I'm going to disconnect it. So I'm going to do that. Now I'm not going to liven the switchboard, so it doesn't matter, but just so nobody is left with any confusion, I'm removing this extra piece of wire we put in there immediately after finishing testing, because if I accidentally left that in and then livened my installation, I would be in big trouble. Bad things are going to happen. Okay, so let's pop back onto our standard then, because I didn't tell you what the reading should be for this socket. What I said was there is a table, and it says it here in our notes. Table 8.2. So let's find that. Let's scroll down to table 8.2 and see what it says. Table 8.1, table 8.2, maximum values of resistance. Now, this is dependent upon the conductor size and also the protective device that is connected there. When I say protective device, I mean typically an MCB, a circuit breaker. The reason for that is because the purpose of the earth conductor is to carry a fault current if there is a fault, and depending on the rating of this device, the fault current of the MCB protecting my circuit, the fault current can be more or less. So a 10 amp circuit breaker will trip with less fault current than a 20 amp circuit breaker, for example. So it's not as important for me to have the same low resistance on a 10 amp circuit breaker as I would have on a 20 amp circuit breaker, because I don't need as much fault current to trip it. So it's entirely dependent on that. Now, it's not super important for us to understand the ins and outs of that. What it is important is to be able to find the right thing on our table. So if we look down the side there, it tells us the size of our conductors, and the one that we were using, so just so you know, is 2.5 millimeter. And the protective device rating, if we just have a quick look there, you may be able to see that, or maybe not. It is a 20 amp C curve. If you can't see that, you'll have to believe me. It's a C20. So let's find C20 on here. So circuit breaker type C and device rating 20, conductor size 2.5 millimeters. I've got the same size active as earth conductor. So 2.5 millimeter and 2.5 millimeter, 20 amp circuit breaker type C. And we've got three columns here. It says RPHE, RPH, and RE. RPH is resistance of the phase wire. RE is the resistance of the earth wire. RPH is the resistance of the two together. And that's interesting because if we think about the way we did that test, we tested the phase and earth conductor together, and we got a reading of about 0.4 ohms. So this table here is giving us that value to allow us to do the test in that way, to test that phase and earth together with the link between the main switch and earth busbar in our switchboard. So if I look down this column, type C, RPHE, 2.5 millimeter cable, 20 amp circuit breaker, you will see the maximum resistance for the earth and phase together is 0.98 ohms, or roughly 1 ohm. And that means that the phase conductor is allowed to be 0.49 or half an ohm, and the earth conductor is allowed to be 0.49 or half an ohm. Our reading for the phase and earth together was around 0.3, 0.4 ohms. So that is a perfectly acceptable test. We have passed the test on that one. As I said, you will then, if you've done this test on that socket, you will now go around and do the test on every socket in that house, everything that you can find. Another way to do that test, if you did not want to put the link into the in here between the phase and earth, is if I'm just testing sockets, I could put an extension lead in here, run that extension lead back to my switchboard, and then test between the earth socket on my extension lead to the earth busbar, and that would tell me the resistance of the earth wire for my subcircuit, but also the earth wire for my extension lead. So I'm going to add that resistance on there. And if both of those resistances combined are still less than 0.49, then I know that's good. But you are going to add quite a bit of extra resistance by doing that, by adding in the earth conductor of your extension lead. So that may not be the best way to do it. It just depends on what your situation is and what sort of results you are seeing. Okay, that's all we need to cover for this one. So that was earth continuity of our main earthing conductor, bonding conductors, and earthing conductors in our subcircuits. Remember the values: main earthing conductor and bonding conductor 0.5 ohms. For our sub-circuit earths, the values are as per table 8.2, which is ASNZ3000. Thanks very much for tuning in. I'll see you at the next one.